where you are. This is possible because behind the curtain, they are using the database which is collected by Google using the little car you see on the bottom of the screen. In Europe, this kind of collection of data made a lot of noise. I don't know if you see the headline on the press, but basically people in Europe was concerned about the idea of Google collecting that much Wi-Fi traffic. That's one of the bad usage that you can do with that. So what happened under the hood is the attacker will emulate this protocol and send the victim MAC address. I mean, if you have the WPA key, it's not as difficult to also get the MAC address. It's on the same page usually. So you take the MAC address, you send it to Google, and Google will happily give you back a longitude and latitude. We did try this on my own router, and actually it found my home pretty close, like 100 meters close to my home. And then you can also use the standard Google Map API. And with that, this longitude and latitude get a map. So you get a key and you get a map. How many of you want to see the tool in action? Everyone. Okay, great. So since we don't trust the god of the demo, we did make a video for you. So no live demo for you, but it was actually done on my own router at home before I changed it. So you see, first step we do the fingerprinting. Then we find the IP address of my routers. Then we have a fingerprinting step. We have the injection, and now we're waiting a couple of seconds because it's a reflected XSS, so we have to input it and wait until the router reboots. It's an old router, so it took like 20 seconds, almost done. And then you will see the WPA key pop up. Here you go, with my MAC address, and then we're going to use a geolocalization, and this is my location. And if you look closely where it is, it's really Palo Alto, and it's really close to where I live. So if you live close to me, well, you're free to buy me a free beer. I would be happy for that. So that's our first demo. In the second part, I want to discuss with you how we can attack HTTPS. We're using what we call cache injection. So a little bit of outline before that, because it might be a little bit confusing otherwise. First, we're going to give you a background how we build a web page. Then we're going to describe what a cache injection attack is. And then we're going to discuss how defense are currently implemented to limit this kind of attack. And finally, we're going to show you how we find a way to actually bypass this kind of defense. So a web page, as most of you know, I guess, is compromised, has multiple elements. The first one is, of course, the HTML body, which contains a lot of links to a lot of elements like images and also JavaScript and possibly Flash. And all these elements can come from a lot of different origins. For instance, a lot of people are using Google Analytics, which track the usage of the web page, which is fetched from Google, and you can also fetch a map from Google. You can fetch recommendation for Yelp, so it's a huge mashup. And on the other hand, every browser, every modern browser, even smartphone browser, have a caching mechanism. So the idea behind the caching mechanism, which is used to improve the performance of the network, is when you request a web page, and this web page contains a JavaScript, which might be reused. The server might send you some header, say, this JavaScript won't change for a couple of hours, couple of days, couple of months. So can you please cache it locally and not ask me again until that amount of time? That's the basic idea. There is more subtle idea how to do that using e-tag and so forth, but that's the basic idea. And then, so next time the browser is going to request an HTML page which are using this JavaScript, instead of doing a request, you're doing it directly from the cache. So net result is you decrease the network load and you actually display the page faster. So everyone has the incentive to use that. Actually, we look at how many websites on Alexa top 100,000 have at least one external JavaScript file which can be vulnerable to caching injection. And we found that at least 43% of these websites have one. Can you guess what is the most common used JavaScript library in the world? At least for HTTPS? Any guess? Google Analytics, yeah, good answer, yeah, that's true. So the one we found in the most website is actually Google Analytics, which is followed by jQuery. And then you have SFW object. It's basically the library you are using for embedding Flash into the page. And the third one would be Google Syndication, which is basically Google Ads. And after that, we have Prototype, which is another library, and Quanta, which is one other analytics. So let me describe now what the attack scenario might be. Assume that the user is very tired and wants to get a cup of coffee. He takes his laptop and go to a coffee shop. Or for what it matters, he came to the Black Hat and decided to browse his email despite the huge warning you have on the page, right? Yeah, be careful. And at that point, he will browse sooner or later a HTML file, which is not encrypted. This file will be intercepted by the attacker, and the attacker will be able to inject in it a link to a script library, a JavaScript library, which will be over HTTPS. So there will be a warning at this point. We're going to discuss that in a few slides, but just bear with me for a second. And this is a malicious version of a cached library, let's say Google Analytics. And this library, if it's accepted by the user, will be in his cache, right? So the library is downloaded by the user, it's in the cache. And later, if the user go back home or go back to the office and feel more comfortable, he might try to, let's say, write a blog post to Blogger, or he might want to try to access, let's say, Twitter. And he fetch a page. The page contains a link to the JavaScript library. And at this point, instead of fetching the real page and the real JavaScript library, he will fetch the malicious JavaScript library from the cache. And there will be no warning whatsoever because you already accepted maybe 1 hour earlier, maybe 1 day earlier, or maybe 1 week earlier, depending on if you clear your cache or not. And at that point, this HTTP session is compromised. What makes this attack even more powerful, and I think that's the thing we really want to raise attention to, is if you are able to cache a malicious library like Google Analytics or jQuery, then you can compromise multiple websites with one injection. So if the user is clicking through one bad warning, then he's get all the websites we are using, let's say Google Analytics, which is about 15,000 of them. Of course, there is defense against that. So that's a third part of this first section. And you have warning. The defense we have currently in the browser to defend against this kind of attack are SSL warning. This is the one from Firefox. It's a very intensive warning. You have to do 3 clicks to go through it. So you might wonder how to inject a malicious shared library. Well, first you can trust the user. I mean, to always trust the user to make the wrong decision. So they're very good at that. And they have good reason actually to do that. This is twitter.com over HTTPS, right? Do you know what happened when you go to www.twitter.com? Well, you get that. Why? Because they are using an EV cert, extended validation cert, and EV cert do not support wildcard. So if the user is trying to put www in front of every domain he wants to access, and that's what he has been trained for years, he gets this warning. If you want to have fun, you can also try to go to https://www.youtube.com, and you get a warning because that's a Gmail certificate. So certificate mismatch is really common. How many of you have ever clicked through this kind of warning? Come on, raise your hand. I mean, don't be shy. I mean, I did. I mean, everyone did at some point in their life. And actually, even this morning shows that, from Qualys, shows that you have actually 92% of SSL certificate which have a CNAME command mismatch. So it's something that, I mean, we try to put a negative warning to the user, and at the same time, almost 90% of the internet and even very, very well-known websites have a bad certificate, which means that we are giving the wrong message to people. So you might say, well, that's okay. We can also have positive warning, meaning we can give security indicator to people. Let me show you what Firefox did for Firefox 4. They did a nice study. This is a heat map of where people are clicking. So green one, which means no click, is a site identity which gives you information about the SSL certificate. No one is clicking on it. If you want to have the detail of the click, well, if you have an extended validation certificate, at most 1.4% of the users are clicking on it. So in the same time, users don't click on positive warning. So, well, this might not be a black hat talk if we're just giving fact and say, well, trust the user. It would be more fun if we find a way to actually trick the user, trick the browser into not displaying the warning. So that's what we're going to show you, right? More fun, right? And more interesting. So this is the IET warning, right? Who is using Internet Explorer in the room? No one. That's amazing. Every time I ask a question, no one raises his hand. That's okay. So this is the standard one, and it's a pretty scary one. They have 2 red shield and say it's not recommended, and they try to filter out the user. And let me show you what actually is happening when we're able to trick the browser. Here you go. So we're going to read a page which has a cache injection. You see the bar on the top? That's your warning, and that's the only warning you're going to get. And the only thing you can do is display block content. That's all. You can't do anything else. It's block. And when you click on it, we just inject you 5 different libraries at once. You might not trust us, so we're going to go to Blogger, and you have the HTTPS certificate, which is perfect, no warning. And we have a malicious version of jQuery in this page. So we're going to type my user and my password, not my real one, and when you click, you're being hacked. But actually, we didn't inject a lot of them. So if you go to Twitter, and even if you don't accept mixed content, so you're going to see a warning when we're going to click on Twitter. That is not because of the attack, that's because Twitter on the top left has images which are not over HTTPS, and we're going to refuse this image. So we're not going to display any content which is not over HTTPS. And you have only full HTTPS here. You're going to enter your login and password. And remember, it's already too late. The malicious JavaScript, in this case Google Analytics, is already in cache, and you get your session compromised. And this will not get away until you clear your cache, because we put that until 2:30. So we're not going to tell you exactly how we did mess up with the UI, because Microsoft asked us to give them time to fix it. We're going to release more detail on this, but that's really easy actually. And we found a ton of this kind of inconsistency. This one is also from IE8. As you see, it's not the same warning. So if you train your user, do not click into the specific shim, while you can also have some different behavior which might confuse even someone who are savvy. We tried to show this attack to someone earlier this week, and actually they get fooled by it. So that's one way. So let's discuss it a bit. Firefox. So Firefox has this warning, right? I showed it to you earlier. And it turns out that Firefox did a very, very good job at being very consistent with this warning, and we were not able to remove it. So not being able to remove it doesn't mean we can't do anything. So we had to become a little bit more creative for that, and we come up with a nice solution. How many of you are familiar with clickjacking? Not everyone. Okay, so just one slide to make sure everyone is on page. Clickjacking works like this. The user sees a page, let's say a game, or download this movie, download this file, click here to accept this agreement, and she's going to click. What happened under the hood is you have a semi-transparent div in front of that, and you are basically aligning the 2 buttons. So when the user is going to click, instead of clicking to start or download, he's going to do something he will regret later. Here, for instance, leaving Twitter. Of course, Twitter is not vulnerable to clickjacking attack anymore, but it's to give you an example. So when you click, basically you do something you don't want. That's clickjacking, and that's something which is not enough discussed, as many people already try to raise awareness about. So, well, applying this idea to warning actually works. We're not able to remove the SSL warning, but we're able to actually clickjack it. So we're not completely able to clickjack it. We're going to show you this in a second, but we were able to remove 2 out of 3 clicks, and it makes the warning kind of confusing. So let us show you that. So basically, you're going to accept the agreement, which is the first click, and then you're going to click to download the game, and that's the only pop-up you see for the SSL warning for Firefox. You confirm the exception, and at that point, the JavaScript library is cached, and you're dead until you clear your cache. So same demonstration, still jQuery, malicious version of jQuery, which is cached, and as in the previous demo, you are able to steal information over HTTPS with not a single warning on the SSL version. Okay, so that was the 2 first part. I'm going to give you Baptiste for the 3rd part. He will going to show you one more attack, and they are all yours.
Okay, thanks. So in the 3rd part of this presentation, let me show you how we can steal private data from users using framing attacks. Framing attacks is an evolution of clickjacking and scrolling attack. Clickjacking, just presented previously by Elie, is a term coined by Jeremiah Grossman and Robert Hansen in 2008. And the scrolling attack is a new attack just showed by Paul Stone in the Black Hat Europe this year. The scrolling attack works as follows. In a first step, the targeted website is double framed. Here, in this example, you can see the mobile version of Yahoo Mail.